which is 1 over 4 plus x squared, right? We're trying to find its power series, correct?
Yes.
And your power series is not there. So let's figure out where you went wrong. Did you start with a function that looks like this?
Yes, I did start with a that function, and then I work it up to the derivative of it.
Okay, so let's find out what went wrong here then. Maybe that's where the problem is. So if you were going to do this function, you could probably pull out a 4, and that would leave you with 1 plus a quarter x. Did you get that rearrangement of g of x?
Let's see. Yes, I did get that.
Okay, so we know that we're going to be doing sigma n equals 0 to infinity. And since that's the plus 1, you're going to get -1 to the n. And this is going to be the x. So it's going to be 1/4 x to the n. And of course, there's going to be a -1/4 outside. So we're going to get -1 to the n, x to the n over 4 to the n. Now, if you bring this -1/4 in, what that does is it gives you another one of these and another one of these. So far, so good.
Yes.
Right. So that is the guy that we're calling g of x, right?
And then I take the derivative of it,
Now, if you
right?
take derivative, you should get that guy, right?
Agreed.
Agreed. So f of x then is essentially going to be the derivative fella. So that's going to be multiplied by the power. Reduce the power by 1. Right, and that's the guy you've got, okay?
Yes.
Now, if you notice that at 0, the thing's wrong, right? The thing's gone. Right, if you plug n equals 0, this is disappear. So I'm going to start at 1. That way I've got a nice guy to work with, which you kind of do with derivatives. Once you differentiate them, you kind of start at 1. And now I'm going to make that an x. Okay, I'm going to add 1 to this guy. I'm going to add a 1 to this guy. I'm going to add a 1 to this guy. And I'm going to add a 1 to this guy. And I'm going to take away 1 from this guy.
So essentially, if I start at 0, everything just disappear. But you just start from 1 instead, right?
Yes, and the reason I started at 1 was that n equals 0, that one starting value of n equals 0, this expression would be 0 when n is 0. So it doesn't really exist. So I'm going to start at 1. Plus I got the benefit that you can dial back once you do this, because the style points is looking for that. So that would have been the answer, and I'm looking, and it's pretty much what they've got. The only difference that they did is that they called it that guy, which is really cosmetic. -1 to the n plus 2 and -1 to the n are both exactly the same in value, because adding another 2 to the power of -1 is essentially just multiplying by -1 squared, which is multiplying by 1. So yeah, I guess you could do that. I wouldn't myself, but I suppose it looks prettier. So that's the answer that they have.
Does it
This is the
still
answer I had.
question? Does it still accept the -1 to the n plus 2, or it
I
doesn't?
don't know if you've got the if you've got it in front of you, type it in. If they don't accept that one, then this one is equivalent and it will accept this one. WebAssign's not a genius, it's software, so it doesn't know that certain things are equivalent sometimes, and therefore it might mark a correct answer as being wrong.
So okay, moving on to the B part, I figure out that let's see. Hold on just a second. If I want to take the antiderivative of 1 over 4 plus x to the power 3, then the previous iteration of function need to time -1/2 to become that derivative of 1/4 plus x to the third.
Yes, I agree. So you're going to do, you've already got the answer to f of x equals 1/4 plus x squared, right?
Yes,
You already have that. So, and we are trying to find the derivative. I wish they would give them different letters, but I'm going to pretend it's called g of x. You're trying to find this guy, right? And you're going to do a differentiation, but to make this kind of work, don't you have to introduce, as you said, a -1/2 to it? Agreed?
Yes, I did try to solve
Right.
the
So let's put that in. So the one that we've got, that's a 0. The one that we had a minute ago, I'm just going to stick to my answer, which is the n+2 version. Right. Right. So far, so good. Right.
Yes.
Now, you got to differentiate because that's essentially this fella, right? That's him.
So do I differentiate? All right.
Okay. So we're going to start at 1 for the same reason as before. Multiply by the power. So you're going to get an n with an x. And that's what you got. And then I'm going to add 1 to everybody. So this now becomes -1 to the n+3. This guy becomes n+1. This guy becomes n+2. This becomes n+3 and x to the n. And you wind this back to 0. So far, so good?
Yes.
Differentiate. Then add 1 to everything that has an n. So all the n's become n+1s, right? An extra 1. Bring in this -1/2, and let's see what we have. We have -1 to the n+4, right? Because I had 1 more there. That guy's the same. That guy's the same. That guy's the same. Can't really do much about that bottom guy except do 2 times 4 to the n+3. And that's the answer that they have. Oh, well, they called this guy n again because n+2 and n+4 all end up being the same pattern of pluses and -1s.
Yeah, it's kind of the same pattern.
Yes. And so that's the second answer. That's what it should have been.
For the C part, I just time it with, well, the previous one time x squared, right? Which essentially make the xn become xn+2, right?
Correct. Yes. And what happened there, so let's show you what that one looks like. So you are just doing an x squared of the guy you already know about, which is the one we just, start again. What you said is correct. I got this big ugly mess and I'm going to multiply it by x squared. Let's say it that way.
Well, which we have already have a x term in that series, so so it is just adding 2 to the power of n.
Exactly, agreed. Exactly. I'm just, God, it takes forever to write this down, but here we go. So I'm going to add 2 to that. Oh, let's just bite the bullet and call that n to keep them happy. This fella here is now going to be n+1. This fella here is still n+2. Like you said, add 2 to the power. And that is not their answer. They may accept that answer, but it's not yours. So what we're going to do instead is remove 2 from this.
So adding 2 to
take away 2. Take away 2.
I see it now.
So that becomes n. That becomes n-1. That becomes that guy. and that becomes n plus 1. And you're going to start at 2 now, because if you take away 2, you add 2 to this, right? So if you take away 2 from everybody, you add 2 to this guy. That's the kind of seesaw, as one goes up, the other comes down kind of thing. And that answer is very close to theirs. They seem to like playing about
Wait,
with that
is
fella.
is that subtracting 2 or add 2?
Add 2 here and subtract 2. Whoops, let's put it in the right place. Add 2 here and subtract 2 there. Subtract 2, subtract 2, subtract 2, subtract 2, subtract 2, and add 2 there.
Wait, should it make it become n equal to -2? Because we
No,
are
2.
Oh.
Sigma, you do the opposite of what you do here, right? It's a kind of seesaw thing, right? So if you're taking away 2 from all the ends here, then you add 2 to here. It basically compensates algebraically for what you're doing here by changing that.
Even though I have an n equal 2, but all of them are subtracting 2, right?
Mm-hmm. You're going to subtract 2 from all of these and add 2 to that guy. Now, if you subtract 5, why you would want to, who cares, right? But if you subtract 5 from all of these, you will add 5 to that. If you add 2 to all of these, you will subtract 2 from that. So whatever you do here, you do the reverse here. Right. Now, this guy here has got a little minor cosmetic. I hope WebAssign takes that one, but this one's equivalent. And this is the one I can see in front of me being used in this question.
Alrighty then.
Okay, so can't remember which one that was. That was question 7.
And then go back to number 8.
8 now.
It also have that same thing that like the +1 and thing on the sigma.
Yeah, that's exactly what it had. And it looks like you got it right. So
yeah, it's well, I got it wrong first and then tried to use the process another and trying to see what I'm doing wrong, but I'm still not understanding what the heck is going on there.
Let's look at this one again. Right, so the function I'm going to start life with is that guy, okay?
Yes.
Now, if you take this guy and you integrate him, don't you get that guy?
Yes.
Agreed? Okay, so let's find the power series for this guy.
Let's see.
You comfortable with that?
I'm pretty sure I can handle this one.
Right. Okay. Now, once you do that, you will get your power series, and your power series will be to integrate this guy, right? So whatever this guy ends up being, the natural log of 9 minus x will be the integral of this power series. Do you want us to go into the details of that, or is this enough?
Let's see. So that should be -19 over x over 9 to the power of n. 19 times the sum of x over 9 to the power of n.
Yeah, right. I think that's what you just said. Let's just write that down.
Yeah,
it's -1/9 times sigma n equals 0 to infinity of -1/9 x to the n. Agreed?
Wait, hold on. I thought that the 1 over 1 minus x result to
that's a plus. You're right. The negatives are a plus. Yeah. Are we good now?
Yes.
Okay,
so we find the well, we integrate that one, right? Or
well, in a minute we will. Let's make it look pretty before we integrate it. I'm just going to keep that negative outside. It's an awkwardness that I prefer not to deal with, right? So that's what the power series looks like. It's a negative, a single negative of all this.
Should the 9 be 9n plus 1, 9 to the n?
Yes, correct. So the natural log of 9 minus x is going to be the integral of this ugly guy here. Okay, so there's that negative again. But if you add 1 to the power and you divide by the new power, you get a guy that looks something like this. So far, so good.
And then I believe that you did the same thing as before, add 1, but subtracting 1 to everything that has an n, right?
Yep.
Or correlate to the n.
Right, so I believe you get that. Agreed?
Yes, I believe that. Yes.
And what do you do about the starting value, which in this case is 0? So if you take away 1 from everybody, what do you do to this 0?
You just add 1, right?
Right, so now you're looking at that plus c. Agreed?
Yes.
Now, what plus c is essentially the value that you would get when x is 0. Right, so if you're trying to think of what number is plus c, the way you can do it is find the value of this function and when x is 0. And when x is 0, all these terms here disappear because all of them are 0 over something, 0 over something, 0 over something. And all you get is plus c. And you put 0 in here, all you get is log 9. So what that means is that this is log 9. So you have log 9, take away the power series. And now you are finished.
Alrighty then. Could we move on to number 11? I believe that we did this before, but I assume, but the website didn't accept the answer. I believe that either we have the wrong note, which I have spotted on the number 10, which we also have a wrong note about the natural log of 1 plus x, or I have done something wrong.
Right. Well, we fixed the previous one. So if I made a mistake in our notes, then hopefully you can go back and say, oh, you should have put a plus there or something. So the fella that we're trying to look for here is the integral of the natural log of x over x, right?
Alrighty then.
So what we're going to have to figure out here is that guy. Now, did I keep those guys? And I hope I wrote them down right as well.
It is, let's see, negative 1n times xn over n to the sigma notation of n equal 1 over infinity.
Okay, n equals 1 to infinity.
Yes.
Of x to the
xn times negative 1 to the n.
xn times negative 1 to the n. Okay.
Over n.
Over n. Right, so it's an alternating guy. Right, so if you want to do the power series for that, you essentially remove 1 from the power of x.
Which make it become x. Okay, I see it now.
Right. Now, if you want to integrate this guy,
wait, hold on. Do I need to integrate that one?
Yeah.
Oh, I need to integrate that one. Oh, okay, I see it now.
So the power rule is add 1 to the power and divide by the new power. So that's why there's an n squared there. And you're looking at that, plus a c.
Okay, so
there's something not right. Is that not 2n?
Wait, hold on. Well, false. That should be x to the 2n plus 1 over 2n plus 1. Mistake.
Yeah. Okay.
My mistake.
And this here on the bottom should just be n or 2n.
Oh, that should be. Oh, I see it now. That should be a 2n. I'm sorry. I was looking at natural log of x plus 1.
Okay, so we got 2n, right? And plus 1, right? And if that's 2n, right, you're going to add 1 to the power, right? And then you're going to divide by the new power. So okay, so this here is 2n plus 1. That's the original inverse tan. So now we get that guy. Okay, now I'm good.
So okay, so if I take the derivative of that, no,
Well, integrate.
integrate, my bad. Let's see. Okay, so then
You're going to do the integral of n equals 1 to infinity. Now, if you take this guy and you divide it by x, you then remove that one from there. So this is the correct inverse tan, right? It's this one here.
yes.
Right. So dividing it by x removes that 1 power. So now you've got an x to the 2 in there. So I'm going to be integrating this fella. Right, that's the inverse tan over x guy. So what do we get? You add 1 to the power. You divide by the new power. Plus c. I'm going to remove 1 from everything that says n. So if you remove 1, you get that. You remove 1, you get that. Actually, why am I bothering to do that? Why don't I just leave it like that and call it good?
Wait,
And
should I
not
leave it as
2n plus 1? Yeah. We want x to the n if we can have it. But anything else that happens, it's probably not worth the effort. So just leaving it as 2n plus 1 is fine. Now, could I turn it into 2n? I guess I could. If WebAssign is clever, it will understand the answer.
But again, as a machine, it only learns it linearly.
Yeah, it only learns what it's been programmed to learn. So this would be the correct thing. And if you're subtracting 1, as I would be everywhere here, wouldn't I be adding 1 here and it would start at 2? Taking 1 away, add 1 here.
Yes.
So this would be also correct. And it's equivalent to this one. This is the one that WebAssign, what I can see in front of me, is the one it was looking for. And this one would be equivalent. If you have 5